All right, fourth grade, let's take a look at our next example. We already have a tape diagram drawn, partitioned, and shaded. Can you tell me what fraction of my tape diagram is shaded? 2/5. You're right. We have 1, 2, 3, 4, 5 equal pieces, and 2 of those equal pieces are shaded in, giving us 2/5. Now, just like we did before, I'm going to drop down and I'm going to create my number line, okay, to show the equivalent fraction. And my tape diagram represented my whole, so I have to drop down and do the exact same thing on my number line down here. I have to represent my whole. And again, I use the tape diagram to help me. And my tape diagram was partitioned or divided into 5 equal pieces, so I have to drop down and do the same thing on my number line. This one's not going to be as friendly. There's no half to help guide me. So I'm going to use my tape diagram to help me draw my fifths, and now I'm going to check it. If these are indeed fifths, I should have 5 equal pieces. Let's count. 1, 2, 3, 4, 5. I do. So now I cannot leave my tape diagram or my number line unlabeled. I have to go back and label my number line. So this section right here represents 1/5. We know this section represents 2/5, just like labeled on our tape diagram above. This would be 3/5, 4/5, and then this would be 5/5, or our whole. Now, we're going to go back up to our tape diagram, and this time we're going to find an equivalent fraction. And we're going to find an equivalent fraction to 2/5 by decomposing our 2/5 into 4 equal pieces. So that means each fifth will be divided into 2 equal pieces, giving us a total of 1, 2, 3, 4 equal pieces within our 2/5. Now, that's going to change our fifths. How many equal pieces will we have now? Let's see if you're right. Okay, let's count them. 2, 4, 6, 8, 10. If you said 10 equal pieces, you were right, fourth grade. Nice job. So we no longer have fifths, we now have tenths. And we can see by looking at our tape diagram that what was 1/5 or 2/5 is now 1, 2, 3, 4 tenths. So now we're going to drop down and do the same thing on our number line. We are going to look at our 2/5, and we said we wanted to decompose our 2/5 into 4 equal pieces. And to do that, each fifth was divided into 2, giving us a total of 1, 2, 3, 4 equal pieces within our 2/5. So now we've got to drop down and do the same all the way down our number line. Okay, and now we should have tenths, just like we did up here in our tape diagram. So let's check it and see. We've got 2, 4, 6, 8, 10. We do have tenths. So let's come back and let's label our number line just like we did before. So this section would now be 1/10. This section would be 2/10 or 1/5. This would be 3/10. This would be 4/10 or 2/5, just like we modeled up here in our tape diagram. This would be 5/10. This would be 6/10, 7/10, 8/10 or 4/5, 9/10, and then last but not least, 10/10 or 1 whole. Now, going back and looking at our number line, we can see that 4/10 is equivalent to 2/5, or 2/5 is equivalent to 4/10. Now, boys and girls, there's something Mrs. Roussel forgot to do. To represent 2/5 on our tape diagram, we shaded those sections in. On a number line, it's a little bit different. We don't shade those sections in, we plot a point. Okay? So now you can see that 2/5 is equivalent to 4/10, or 4/10 is equivalent to 2/5, just like is shown up here in our tape diagram. Now this is pretty cool because I see more than one equivalent fraction. We can see that 2/10 is equivalent to 1/5 and 1/5 is equivalent to 2/10. We also see that 3/5 is equivalent to 6/10 and 4/5 is equivalent to 8/10. How cool is that? Now, I want to show you, sometimes mathematicians will represent these equivalent fractions using a number sentence. So we said that 2/5 was equivalent to 4/10. So let's talk about how mathematicians write that as a number sentence. We broke our fifths into how many equal pieces? You're right, 2 equal pieces, and that gave us tenths, 10 equal pieces in all. And then our 2/5 that were shaded in, when we broke those into 2 equal pieces, we now got 4 equal pieces, giving us 4/10.